Okay, the next set of problems we're going to do are optimization problems, where we're finding distance from a curve on a graph. Now, these can be a little misleading because you're going to think I just gave you a primary equation and I didn't. Y is x squared plus 2 is this parabola, and I want to know what points on this curve are the closest to 0.06. All right. Now, it's not entirely obvious what angle that should be at. Should it be horizontal or should it go up? You remember your distance formula. The distance from this curve is going to be the square root of x minus your x1 value, whatever value you're given, squared, plus y minus y1 squared. This is your primary equation on a minimizing from a graph, distance from a graph. Now, what is my x1 and y1? Well, that's 0 and 6. So my distance is the square root of x minus 0 squared plus y minus 6 squared. Now, this is my secondary equation. So I'm going to plug this into my primary equation. So my distance formula is the square root of x squared plus, now y is x squared plus 2 minus 6 squared. So let me rewrite this. This is the square root of x squared. Let's see, so this is going to be x squared minus 4 squared. I'm going to write it out for you. And yes, we're going to have to multiply this mess out. So this is the square root of x squared plus x to the 4th minus 8x squared plus 16. Now, oh my gosh, this is the square root of, let's see, x to the 4th minus 7x squared plus 16. Now, good news and bad news for you. The good news is in order to minimize this distance, all you really need to do is minimize the inside function. All right, so I want to minimize the function x to the 4th minus 7x squared plus 16. And that will give me the minimum distance for my function. Now we need to look at the domain. All right, we know that this whole thing has to remain positive. We can't get any negatives under our radical. The domain for the function itself is all reals. So we're just going to have to make sure we don't mess that up too terribly badly. Let's see. Now let's take the derivative. F prime is 4x cubed minus 14x. Now, where is this going to be 0? Well, let's see. It's going to be 0. Can I pull a 2 out? Can I pull out a 2x? So this is 4. So this is 2x squared minus 7 equals 0. All right, so when x is 0 and when x is plus or minus the square root of 7/2. All right. Well, that's not a very pretty number, is it? What we need to do is now we need to do some testing. I need this derivative to be positive. Let's see, where is it positive and where is it negative? Let's look at our ranges and use the first derivative test. Let me look. Square root of 7/2 is about what? I don't know what that is off the top of my head. Oh, it's 1.87. So, did I get that right? Yeah, 1.87. All right, so let's test our points. For convenience sake, let's look at x equals what? Let's try negative 10. All right. What is the sign of my derivative at negative 10? Well, this is going to be 2 times negative 10 times, that's 200 minus 7. So this is going to be negative. All right. So then let me check at my next point. X is negative square root of 7 halves. So this is going to be 2 negative square root of 7 halves times 2 times 7 halves minus 7. So this is 0. So this is a critical point. Next, let's test at x equal, let's pick a number between negative 7 halves and 0. So let's try negative 1. So this is 2 times negative 1 times 2 minus 7. So this is negative. Oh, so this is positive. So we see right here, we have a min at x equals negative 7 halves by the first derivative test. All right, so now let's look at x equals 0. Then the first derivative is 0. And now let's continue going this way. Let's look at x equals positive square root of 7 halves. And we have 2 square root of 7 halves times 2 times 7 halves. Whoops. Minus 7 is 0. I should have looked at x equal 1. Happens. At x equals 1, it's 2 times 1 times 2 minus 7. So it's negative. So here, again, we're going from, is it negative? Yep, sure is. All right. And finally, let me look at x equal, let's do plus 10. So this is 2 times 10 times 200 minus 7. Okay, and this is positive. So again, we have a minimum at x equals 7 halves. All right, so the answer to the question is the points on the graph are when x is negative, plus, and minus 7 halves. So what are the y values? Well, it's going to be square root of 7 halves squared plus 2. And it doesn't matter. It's going to be the same value here. So this is going to be 7 halves plus 2. So this is 7 plus 4 divided by 2. 7. So it's 11 halves. So my 2 points are plus or minus the square root of 7 halves. And the y value is 11 halves. All right. Give it a go. And just be careful. Stop the tape when you're done. Finish your homework.